Oh, welcome to Desk of Ladyada.
Hey everybody, and welcome to my desk. It's me, Lady Ada. We're here at my desk for some late night hacking. Mr. Lady Ada is behind the microphone, behind this video deck, behind the computer.
And simultaneously taking care of a baby at the same time.
Yes, good work with that.
That's right.
Uh, yeah, so we got some fun stuff at the desk today. We're gonna wrap up in about 20 minutes because we do have to give somebody a bath.
Me.
No,
I smell like a horse.
yeah,
Okay.
I smell like milk. Okay,
Uh,
so at the desk, well, this week we have been playing. Well, we've been getting a bunch of stuff into the store, which is good. We've also been playing with electronic toys that
yeah.
we've got around the house now that there's a baby.
So let me show you what I'm talking about and what Lydia is talking about. So this is from Baby Einstein, and it's one of the more popular kids' toys um, for infants. And it just kind of does one thing. You just press the button, it does stuff. But as
Plays
we've
music.
seen in the comments on our videos about this, every parent is like, I would absolutely love to change the songs. I would like absolutely love to do other stuff with it.
It
So
only plays like four songs, and it's like after a
yeah,
while, you're like, okay, I've kind of heard the song. I'd
yeah.
like to play
So
something
check
else.
out the full video. We did a midnight teardown after we put our kiddo to sleep. This is gonna be funny because like one day she'll look back at this, but like at night we hack her toys. So the idea behind this is we replace the circuit board. We make it so anyone can replace the circuit board, and then you can drag and drop any music files you want. We're gonna do the Cure, Prince, Joy Division, you know what babies like,
Yes,
and
and our
so
parents are going to sing along with the baby and not get annoyed after a while
yeah,
because mental health of adults is also important.
yeah.
Listen to the same song. If you're listening to the same song, it might as well be a song you like, but they don't have licensed,
Yeah,
Depeche Mode
and you never
music
will.
players.
Like that's the thing. And I think just how music licensing works and everything, you'll be able to put your own music on it. Now the cool thing is the enclosure is identical. Everything stays the same. We're actually going to have a mode that will reproduce the functionality exactly. We'll put the same songs on and everything. But then you want it to do other things on its own. So it could like could wake up at a certain time and say like, hey, you're 47 days old. It could do temperature. It could send it to. It could do some data logging, accelerometer stuff. There's a lot of fun things it can do, but it'll look identical on the outside. We're going to change the outside too, but this is just the first step.
Yeah, so yes, we did this whole tear down. So let's maybe we'll go to the overhead. I'll just quickly, I mean, I'm not gonna
Yeah.
do the whole tear down, but
Just by the way, a little side note because I had to look this up. I'm like,
yeah.
how come?
What's the intellectual property
How
of
come they
Phil?
could call this baby Einstein with a trademark? Well, turns out there's a licensing company for Einstein. Einstein is now one of the more wealthy dead celebrities, up there with Elvis and Kurt Cobain. So they had to pay, or they made an agreement. This company that first did this with the Einstein group, the estate. And then I was like, well, how come Disney Plus has a show called like Young Einsteins or Little Einsteins?
Yeah.
Well, Disney bought this company, and they probably had something contractually allowable that they can do. So these like because I'm like, well, what about the bagel place? Einstein Brothers, I think is okay because I think that was their last name. But
Yeah.
anyways, look up the Wikipedia page. I'm just like, that's neat. So, anyways, I think something like 400 million in revenue. This company was clocking in for all of their toys and more before they got bought by Disney, and then they licensed it out to another company. So, anyways, I thought that was neat. So we're gonna go to the overhead.
Yeah, I mean, it was interesting. So these are, fairly well-made toys. I mean, one thing about baby toys is first off, they have to be very inexpensive. But on the other hand, they have to be very durable, right? Because kids love to like throw them in the, floor and into like a pot of water or the bath or yeah, out the window or, chew on them. So there's a certain durability, which I do like to the designs. They also have to last a long time. They have to, usually last through many generations of kids. Often they're handed down for many years. So we took this apart and there's a couple little just details of that make it very nice. Like there's hot glue that's used as strain relief on the wires and on this switch here that changes modes and turns it on and off. Yeah, first off, it's a fairly nice switch, but also they used heat shrink because this is exactly where if it gets bent or shaken or vibrated, these solder joints are going to fail. It's an epoxy blob, which is expected. Inside is some, very low cost 4-bit ROM microcontroller, which is programmed, once at the factory. There's no flash. You can't reprogram it. So people are like, oh, can I just upload my own songs? No, you can't. It's not like it might be an 8051 underneath, but there's no flash memory that you can change. It's in ROM. Um, what is nice is it's like a single-sided board, so it's pretty simple, and it screws in, so that's kind of nice. There's no glue here that you have to like heat it up with one of those like iFixit kits. So we just have to replace this PCB with another design. And, I'm probably just going to keep there's this elastomer pill button here. There's only one button. And when I chatted with Phil, like we can, the interface could support four buttons. But he's like, no,
Yeah.
just do one. And, you always do another version later. So we'll probably just have the same holes so that this piece can be recycled, right? So it's as close as possible. And then the speaker over here is an 8 ohm um, I think quarter watt. I kind of peeled this off a little bit. You can sort of see. It might be hard to see. It's stamped on. It says 8 ohm quarter watt. So that's not uncommon. We actually have stock basically the same speaker in the shop. We call it like a thin plastic speaker. Very common in toys and gift cards and stuff. Um, and so you get this like almost every toy store has this particular thing. It has two AA batteries.
They're really low cost, and everyone in the chat has these. They're like, "Oh yeah, my kids has these." So
Everyone has these.
everyone has these. It's like standard issue, and when I was doing Make Magazine, and Popular Science, and Hackaday, and 2600, every person, especially tech person, is like, "I'm gonna hack the baby toys." Well, you're too tired. You never do. So we're gonna help you.
Yeah.
We're gonna help you do this.
Because actually it's quite a bit of work, right? Like once you get the board, it's probably not too hard. So then the question is, what the engineering is like, well, what do we want to put in there? And so there's kind of like two options. Either we could go with something like an RP2040, right, which is really fairly low cost. I mean, it's never going to be as low cost as whatever they made here. This is mass manufactured. Like you can't beat somebody who's making literally millions of these a year for cost affordability. But the RP2040 and have flash memory, right, and maybe the songs are stored on the flash, and there's like an optional SD card slot if you want to toss an SD card in. And we would play wave files or we can actually play MP3s on the RP2040. It's a Cortex M0 Plus, which usually, it's not a very powerful processor, but, maybe with the dual core and the fact that, I think we did 16 kilohertz MP3. So you can do them, just not really like amazing
Yeah.
quality ones, but that's okay. The speaker isn't that great anyways.
Will this be the first baby toy that has like high quality audio or like supports Ogg Vorbis eventually or something?
Yeah, I mean, I think there's an Ogg Vorbis decoder for
Yeah.
microphones. I honestly haven't used it. I was probably gonna just use waves because
Yeah, I'm gonna use waves.
waves are like really, they're easy to decode. They're
Look, it was
easy
good
to,
enough for me when I was a kid. It'll be good enough for my daughter.
yeah. Although MP3 is openly licensed now, you don't
Yeah.
have to pay to embed MP3s and
Yeah, I don't
stuff.
want Fraunhofer coming down here
No,
shaking down my kid
no.
for
Shaking on the
milk
baby,
money.
and the baby only has like two possessions, the pacifier and like a plastic ball.
Yeah.
So that's one option, the RP2040. The only thing is that there's no SD, there's no there's no USB slot anywhere. And I didn't want to do anything that required like cutting the
No,
plastic because it's gonna
no.
like leave little sharp bits.
Plus, everyone will freak out online. They'll be like, "Oh, you modded the case. Your baby's gonna choke and die."
Yeah,
So what we want to do is the outside is gonna be identical.
yeah. So then if you're gonna use your RP2040, on one hand it's low cost, it's really simple, but you'd have to open it every time you want to change the songs because there would be like a
Yeah.
micro
You have
USB.
to change the battery once in a while, anyways. But we don't want to do that.
Yeah, I mean,
At least not immediately.
yeah, you're gonna have to change the batteries, but I kind of didn't want like that is a different thing. That's like one screw on the back, and it's not too bad to open. Whereas this is a little bit more annoying. So then the second option is we go with something like ESP32, C3, or S2. Those are kind of my two options. And the reason is that those both have a ROM bootloader. You don't need a separate USB serial chip for them. And they both come in like nice little FCC modules with antenna. And then you could upload the files over Wi-Fi because we have in Circuit Python, and also honestly in Arduino they
Yeah.
have it too, a file uploader setup, and then both can easily play waves. Or I don't think we have MP3 playback in Circuit Python,
So give us a reason to look
but we
into
should
it.
probably add it, to be honest. I think there is an ESP32 there's an ESP32 MP3 decoder for the Tensilica, and RISC-V, maybe they do too. The C3 is tempting just because it's very low cost, But the issue is it never shows up as a disk drive. So, you would have to use the Wi-Fi. I kind of like the S2, it's not as cheap as the C3, but it does show up as a disk drive. So for people who are like, look, I don't want to have the Wi-Fi enabled because that's weird and it uses more power. You would just use, in disk mode, you'd open it up. But for people who want to do like, okay, I want to drag files over, you could do that. And of course, there'll be an SD card as well. So we kind of have to figure out like, even though it doesn't really matter what we choose, I kind of like to think through the process of, um, what our design decisions we're going to make.
Yeah, and check out our video. We're gonna post these as a series. We just scanned in the PCB. That'll be the next thing
Yeah.
later.
So the next thing I got is, Phil scanned in the PCB. I'm gonna take the PCB. I do a trace. I basically, I rasterize it into monochrome, and then I simplify it, import it into Eagle as like a background image, and then I trace the design. I've done this before. It's not too bad. You just trace the holes and the slots, and then now that I've got that, I save it into my GitHub repo. We'll make a GitHub repo for all this, of course, and then I can start laying out components. So, I think I'm going to have a couple different options for people to upload files because I think if people are going to use this and they're going to, it's going to be parents, like they're going to be really tired. They're not going to want to like dick around with Wi-Fi. There needs to be a way for them to have the files upload over USB, over SD card, and over
Yeah.
Wi-Fi. I think that's. I
So
mean, it doesn't cost that much to do all three. You just
yeah,
have to make the decision ahead
to
of time.
change the battery, you have to use a screwdriver anyways.
Yeah.
And so we could also be slick and like slip a little SD card reader thing through the battery compartment. But anyways, there'll be some neat stuff ahead.
Yeah, there's
And
no. I mean, to keep it from being, it's not waterproof, but it's slightly water resistant.
yeah,
There really isn't any
put this
slots.
under the.
Yeah, there's not
Yeah,
really
you'd
any
have to Dremel through, and now you're dremeling.
really drumbling. I mean, you'd have to desolder already to remove this from the battery
Yeah.
supply and also,
I,
change the switch. So
yeah.
already it's like that's a little bit as
I also
much.
like the idea that any parent with a screwdriver could just swap out the board
Yeah.
and you're done. You don't have to do anything extra. So, anyways, that's what we're working on.
Yeah.
So,
Okay, so
yeah.
that's my hack. Okay, cool. So we're gonna move on to the great search.
Oh, one thing.
Wait, do you want to go to? Yeah.
No, I just want to mention one thing. So we just posted up the video for the floppy stuff. We got back on it after the holidays. I had to, bring a child into the world. So the floppy feather wing tester and the floppy feather wing Ruben capable video is up. So, anyways, check that out. But let's do the research.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Thank you, DigiKey. Every single week, Ladyada uses our power of engineering to help you. Yes, you find things on digikey.com. Ladyada, what is the Great Search of this week?
Okay, this week I'm replacing this toy. Let's go to the overhead and I'll show the toy. And we're redesigning this PCB to have a different microcontroller.
Yeah.
And I
By
want
the way, that's the outside.
that's the outside. And so I'm gonna, I know I'm gonna use a microcontroller or something, and all of my controllers I'm thinking of using, basically none of them have DACs, or they don't have DACs with DMA in them. And so instead of fighting an 8-bit DAC on an ESP32, I was going to use I2S as an audio output because I wanted to have fairly good quality audio, and I wanted to drive the speaker directly. And so, historically, I've used the Max 98 357, which is very, very popular and really wonderful I2S amplifier that it has, only one little weird detail about if you change the clock rate, sometimes it does a little bit of a pop on Raspberry Pi Linux, but otherwise it's a very good I2S amplifier. And I was going to thinking of using that, but I thought maybe I would take a look and see if there's any other good options. So let's look at the computer. So this is, again, the chip that I tend to use, and it's extremely popular on DigiKey. You can see there's 50,000 in stock almost. 43,000 here, and then another 6,500 available at the factory. So, this is a great I2S amplifier chip. And one of the nice things about this, in addition, is it doesn't have an M clock input. So it's really good if you want to save one pin. But I also, I've used this chip for, like almost like a decade, it feels like. So I wanted to see if there's any other good options. Not saying that this is an option I'm going to go with, but it's always good to take a look at some other possibilities. So I want to look in audio amplifiers and I want to look at active surface mount sensors. And I'll tell you one thing that is interesting, which is you can search for this. The amplifiers that are, I'm going to say normally stocking and not look at marketplace just for now. One interesting thing is if you look at the amplifiers, like for example, this IS31, the first one, this one is a analog input one, not a digital input one. So in this topic, the audio amplifiers, there's mixed analog input and digital input. And so, the challenge is that you want to narrow down as much as you can, but then you will have to search through the data sheets to find some good options. That said, there's a couple of things you can do to simplify things. Like for example, nothing that is 8 pins is going to be digital input. Like this is like a microphone capsule input. Nothing with 8 pins is going to be digital, because if you're going to do I2S, you need M clock, B clock, LR clock, and data. So that's like 4. And then you need power and ground. And usually you have more than one power and more than one ground. And you need the 2 speaker outputs. And now this is 8, but that's that's assuming no other inputs. And if you have I2S digital, you almost always have I2C input, or you have a mute or a shutdown pin. Basically, you don't have 8 pins. It's very rare to have. I bet you've never seen an 8-pin I2S input chip other than like the CS 4434. And that's not a speaker driver. So what I decided to do to kind of simplify this is looking at first off, I can filter on the power. So I have to drive this 1/4 watt 8 ohm amplifier. So the first thing I did is I just filtered out anything that was less than 300 milliwatts, 8 ohms, and then no speaker amplifier really is going to be for the pricing I'm willing to spend, which is, I'm not going to spend a couple dollars, is going to be more than 10 watts. So I can filter out and just look at that. Second, I don't want, I want either like 1-channel mono or stereo. I don't want just headphones. I mean, I don't mind if it has also headphone output, I guess. So that's fine. Although, I think 2-channel stereo is going to always be more expensive. And then, of course, you definitely are not going to fit that into an 8-pin chip. Next, I can do power supply, but I think I'm going to leave that for last. Okay, and then there is package device. So like I said, I think that I'm not going to look at anything with 8 pins. It needs to be 9 pins or more. And I also, again, do not like BGAs in my process. It's, very time consuming to debug them and to place them. And so I'm going to search only, and I don't want anything that's 48 pins. I'm going to go to 32 pins maximum. And then I kind of selected out all the BGAs. There's a lot of BGA amplifiers I found out while doing this. I also don't think I want 20 SOIC. That's going to be way too big. Get rid of these BGAs. Get rid of this BGA. More BGA removal. 60 SOIC is, maybe that'll fit. That'll be fine. Okay, so let's look at these. Also, our internet's much faster today, which is kind of nice. Okay, so, and then for pricing, let's look at pricing for 500 pieces or more. And so there are features like I2S, I2C, and those definitely will be digital. But I'll say that there are some that didn't have I2S in the list that were I2S. So just something to watch out for. Another thing is voltage. I want something that'll run off of, I think, 3.3 volts. So I'm going to narrow the search here. And then sometimes I don't have the power supply. So I'm going to remove everything that needs 8 volts because I don't have 8 volts available. Okay. So now we've got a couple options. And I'll look at the mono ones later. But like I said, these are mixed together. So this one, for example, is analog input. And then so are the PAM series, etc. Let's look at maybe mono instead of looking at the stereo. Let's look at only mono. Okay, let's see what we got. So down here, let's see, the Max 98 is down here. Yeah, so the Max 98 series is down here. Oh, let me look at multiple. Let's show. Oh, by the way, I've never shown this. You can have a display like many more than just 25 at a time. So the Max 98, 358, and 57 are down here. So, this is ones that have a lot of stock in them. So I actually went through and I kind of searched each one to see which ones were analog and digital. And that just meant going through the data sheets. But it was worth it because I did find one that had that the pricing was a little bit less. It's about $1.50 in quantity. The TFA 9879, and this is actually a pretty nice amplifier that was available. So let's look at that. It has I2S input. So I immediately honed in on okay, it's got an I2S input bus. PCM, 3.3 volt logic. It runs from 2.5 to 5.5 volts, so it's great. I'm going to have a little booster on my design because it runs off 2 AA's. So I'll have to run it at 3.3 volts anyways, so this will be fine. It also needs a 1.8 volts digital supply, but that's fine. That's not for the amplifier, that's for the internal logic. And another kind of neat thing is that there is a I2C interface, which is a little bit more complicated, but it does mean that it has, let's find it. It's got some cool I2C stuff that you can do. It's got a built-in DSP with digital volume control, which I thought was really nice because oftentimes in your MP3 player, this might be MP3 playback on your microcontroller, you don't have a volume control setting. That is a separate, thing that usually is handled as a post processor. And most MP3 decoders just take whatever digital input and they just kind of blast it out into the I2S data. And then, sometimes you can do a multiply, but sometimes you may not have as much time to go through and multiply out every data sample before it gets shipped out. So having the DSP here on the analog output means that you could remotely or with a potentiometer that's not in the signal path, use that to tweak the audio volume. And there's also an equalizer and bass and treble control. So I thought that was, zero crossing volume control, power limiter, basically a very nice, I2C control interface for this very low cost amplifier that's also Class D. So you're going to get good performance. It's good for what's funny is it says good for portable gaming and MP3 players. So while, I may still use the, Max 98, 350, 375, I tend to use. I'm very interested in this part. I think it's a not often used. I've never seen this used in other people's designs, whereas the Max 98 I've seen a lot. But this is definitely my pick of the week for interesting chip. I'm probably going to make a breakout for this because I like the parametric controller I2C. I think that would be really useful when you can't do that on your microcontroller when you're doing your audio playback.
And that's a great search.
Where in the world is that part I need? The great search with DigiKey.
All right, questions.
Yep.
We're gonna do it, and then we're gonna bounce. Ready?
Yep.
First up, with a toy hack, is there enough room to put a small PRS sensor under the part? The LEDs blink, have a motion activated tune.
I think I would add a STEM QT port because there's a lot of space in the guts of the device, and you would just plug in whatever sensor you wanted.
Okay. How about C3, but only turn on Wi-Fi when you stick a magnet in a certain place with the thing inside that knows it through the case. Like,
Yeah, it's actually one of the things that Phil and I chat about is like how do we, make maybe you make it so Wi-Fi isn't always turned on.
yeah.
Magnet sensor or like a orientation
Yeah.
sensor.
Here's the good news. There's so many people. They just need a little bit of help getting this project started that we're going to see probably the biggest toy innovations ever. And the neat thing is everything's open source. And I think this is going to spawn a new um, industry of smart toys because there seems to be stagnation because it's always been a race to the bottom for price. But that's now possible for everything. Like you can get like basically Linux on a chip for,
Yeah.
and I think there is value. If these things are like these toys are like $6 or $7 on Amazon, I think parents would pay $12 if it did everything and it saved them a lot of time and it didn't drive them crazy. Next up, what is I2S anyways?
I2S is a digital data format for audio. It's basically what all audio uses these days because it's less susceptible to noise and static because a digital pathway, right? And it only turns into analog at the very end where, your example, you have this amplifier speaker.
Yeah.
So a lot of chips don't have analog outputs, but they do have digital ones.
Next question, Ada Toys question mark, a line of Adafruit baby toys that are all open source hackable. Well, here's the thing. If that makes sense, we'll do it. Like we're told this is the cool thing about being an independent company that's supported by all of you. We're open source, no loans, no venture capital, no board. We didn't blow all our money on like the metaverse. So we can do things that are risky and interesting and innovative.
Yeah.
And this might be one of them. I put this in the chat. I'll mention it anyways. There's a lot of neat things with AI. I have opinions about AI. There's lots of great uses for it. There's lots of uses that can be further refined and defined. But one of the things that I want to do is an AI teddy bear, kind of like a Teddy Ruxpin, if you're familiar with that. But it would be a rule set that's like you're meant to talk to a child. What are the things that you want to say? And it's data sets that are wholesome and interesting for young people. Because I don't want kids just to like, oh, I could talk to an Alexa or something like that. So, anyways, that's coming soon. That's a little preview of a top secret. And I think that, oh yeah, Adafruit Mastodon instance. Yeah, we're on Mastodon. Let me just post a link in there.
We have the toots.
We toot.
He toots.
We toot.
There's a lot of tooting going on.
We toot.
Whole lot tooting. Whole lot tooting.
Yeah. So yeah, one little side note too. We've been on there since 2017. We were there before it went mainstream.
Yes, I do.
We got ours on vinyl.
We're like hipster Mastodon.
Yeah. So.
Okay, let's rock it because it's 11. It's bath time.
Yeah. If pairs customized sounds with drag drop to SD card, I think that'd be the most probable method. Yeah, I think so too. Okay, last one. This is really last one. If the microcontroller gets faster and more RAM, will it be possible to run Linux? Yes.
Yes. There are microcontrollers that can run Linux.
Yeah. There's more coming and more around every single day. Okay.
Okay.
That's our show for tonight. Thank you so much, everybody. It's now time for a bath. Bye-bye.
Bye, everybody.